thank you for coming this evening. This is the last in the first-year program lecture series for this academic year. This is a program that's been going on for 6 or 7 years, judging from the posters on the walls up there in the freshman chemistry office. It's been supported all that time by the Dean of the College of Science, Joseph Newton. You can see here a few of the slides showing you the variety of topics that have been covered over time, everything from chocolate to renewable energy to solar power to fluoride in water. So we have a variety of topics, most of them at least nominally related to chemistry. I want to thank Dow Chemical for making contributions to the support and upgrading of our stockroom. I want to thank the people who published the textbooks you use, Cengage Publishing, for supporting this program through the years. They kicked in especially for tonight's speaker, in fact. And so with that, let me get on to our speaker tonight, Bill McKibben. He is a Schumann Distinguished Scholar at Middlebury College in Environmental Studies, a Fellow of the American Academy of Arts and Sciences, 2000 winner of the Gandhi Prize and the Thomas Merton Prize, holds honorary degrees from 18 colleges and universities. He's been named by Foreign Policy as one of the world's 100 most important global thinkers. The Boston Globe said he was probably America's most important environmentalist. He's a leader of an organization called 350.org. The name, I'm sure he will explain to you if this poster is advertising him properly. He has led numerous rallies and demonstrations in support of his goal of helping us to get control of greenhouse gases, which he and the scientific community are now fully in consensus are driving global warming. 25 years ago, he wrote a book called The End of Nature. At that time, all of those endorsements I referred to from scientific organizations did not exist. But since that, he wrote that book, the first general attempt to explain the origins of global warming. There have been 5 intergovernmental panels on climate change. Even by the second, it was evident that there were serious problems. These problems have been acknowledged and endorsed by more than 30 national academies of science, societies in chemistry, physics, biology, oceanography, geophysics, geology. So there's a strong scientific support for problems that Bill McKibben wrote about 25 years ago. So with that, I want you to give a big Aggie welcome to Bill McKibben.
Well, y'all, howdy. Very, very good to be with you today. I've been looking forward to coming here, and it was a great pleasure. You know, I began the day in Austin, and I understand, and got to drive up and look at the beautiful wildflowers coming into bloom after this cold winter, and it was a great, great pleasure. And it's a great, great pleasure to come here, and especially to talk to you all, because much of my time, I find myself often talking to, English majors and history majors and things, and it's fun to be with scientists for a while, chemists, and get to talk about chemistry, because that's what underlies this difficulty that we have stumbled into as a species, probably the greatest difficulty that humans have ever encountered. And it's a fascinating and kind of unlikely story, and I thought I'd tell it for a minute, just to I know you kind of know about global warming and climate change, but just to bring you kind of up to where we are. The story really for all practical purposes, starts in the late 19th century with one of the greatest chemists of all time, the Swedish chemist Svante Arrhenius, who won the Nobel Prize later for other work. But as a young man, he became interested in this question of what would happen if we continued mining, at the time mostly coal, and burning it. We already knew a little bit about the molecular structure of carbon dioxide. Whenever you burn coal and gas and oil, you get carbon dioxide as an inevitable byproduct. And not just a little bit, it's not a trace gas. I mean, if you take a gallon of gasoline, which weighs, about 7.5 pounds or so, you all have probably filled the lawnmower with a gallon of gas before mowing the lawn. If you take that and you burn it, you get a lot of minimal quantities of dangerous trace gases, carbon monoxide and things like that, things that'll kill you if you breathe them in enough quantity. But you also get a large amount of carbon dioxide. In fact, since each of those carbon atoms combines with a couple of oxygen atoms in the atmosphere, that when you combust it, that 7.5 pounds or so that comprises that gallon of gasoline turns into about 22 pounds of CO2 when you burn it. And what Arrhenius was among the first to try to calculate was what that increasing amount of CO2 in the atmosphere would do. Since the molecular structure of CO2 traps heat near the planet that would otherwise radiate back out to space, he speculated that it would begin to noticeably heat the Earth at a certain point. And what's remarkable is that his back-of-the-envelope calculations in the 1890s are remarkably close to what our supercomputer climate models yield today. He said, as he put it in those days, if we continue to evaporate our coal mines into the atmosphere, we're at a certain point going to have a significant effect. Now, of course, that effect came sooner than he thought, because the story of the 20th century was that we became incredibly good at discovering, mining, drilling, refining fossil fuel in all its forms, coal, gas, and oil, and hence pouring it into the atmosphere in very, very large quantities. For most of the 20th century, we didn't pay that much attention to this phenomenon. The theory popular among most scientists was that the oceans would be able to absorb all this excess carbon dioxide that we were producing. But people finally decided to test this theory in the mid-1950s when a couple of oceanographers at the Scripps Oceanographic Institute in San Diego performed the necessary experiments and calculations, and what they basically discovered was that the oceans were already at saturation for CO2. And what they postulated, therefore, was that most of this excess carbon must, in fact, be accumulating in the atmosphere. And so in 1959, a young graduate student named Charles Keeling, went to one of the more remote places on the planet at the time, the shoulder of the great volcano at Mauna Loa in Hawaii, and he put up an instrument that still stands. I've been there to visit it. It's an important scientific instrument on the planet, though it's fairly simple. All it does is record the amount of CO2 in the atmosphere. And what they discovered within a very few years was that, as they had predicted, the amount of carbon in the atmosphere was steadily increasing, in fact, at an accelerating rate. It was indeed accumulating in the atmosphere, and as they put it then in the late 50s, we're conducting a great experiment on a planetary scale to see what happens when you put this much carbon in the atmosphere. we were unable until the 1980s to really predict with any accuracy what that accumulating carbon would do. It was only in the 1980s that we acquired computing power of sufficient strength in order to really begin to model the effects of this carbon on the atmosphere, because of course it's a very difficult modeling problem. You have to figure out at a number of interfaces, both vertically and horizontally, what happens as this extra carbon accumulates. But by the late 1980s, it was becoming increasingly clear that we were indeed on the edge of heating the planet in a pretty remarkable way. In 1988, our most important climate scientist, a NASA scientist named Jim Hansen, testified before Congress that this extra carbon that was pouring into the atmosphere was already noticeable. He said it's time to stop waffling and just admit that we are heating the Earth. Now that was a remarkable declaration, and remarkable declarations require remarkable proof. So of course, science went to work with its dialectic process, its kind of adversarial process. Quickly, every atmospheric chemist and physicist in the world was trying, as scientists do, to disprove this hypothesis. I remember in the early 1990s when Mount Pinatubo erupted in the Philippines, the biggest volcanic explosion of the last few decades. And it offered, in fact, a remarkable way to test some of these climate models, because it was pouring measurable quantities of different chemicals into the atmosphere, and you could run them through these models and begin to test their accuracy. And there was a scientific meeting in Hilo in Hawaii, the important atmospheric meeting that year. And for the first couple of months after the explosion, it did not look as if the climate models were doing a very good job. Temperature wasn't changing precisely as they had predicted. And scientists, as is their wont, some of them were attacking Hansen and the other climate scientists and saying, your theory is suspect. And I remember Jim Hansen standing up at that meeting and saying, I think this is one of these cases where the theory is right and nature is wrong, which was an audacious thing to say. And beginning about the next month, the temperature data began to track with almost eerie precision the chart, the path that Hansen et al. Had predicted. By the time that episode was over, the confidence of scientists in those climate models was far more robust. And by 1995, the world's climatologists, atmospheric chemists, atmospheric physicists had reached a strong working consensus that indeed we were heating the planet and that it was going to be a very significant problem. They'd gathered themselves together in a group called the Intergovernmental Panel on Climate Change, authorized by the UN to study this phenomenon. One of the great chapters in the history of science. And their conclusions, announced in 1995 or so, should have been the point at which the world began to react, the world's governments and things began to enact policies to do something about this. Because it was very clear that we were courting enormous danger. To understand how much danger, you need to look backwards a little ways into the period of time that we call the Holocene. The last 10,000 years, the period of time in which human civilization has arisen. And during those 10,000 years, the climate was remarkably stable, and that's because the levels of CO2 in the atmosphere were quite stable. It stayed at about 275 parts per million over those 10,000 years, and hence we had a very equable climate, and hence we had the conditions necessary for civilization as we know it to develop. But beginning a couple of hundred years ago with the first coal mines and accelerating enormously to the present day, we've been digging up all sorts of carbon. All those plankton and dinosaurs and ferns and whatever else that had been buried beneath the surface of the earth, compressed there, turned to hydrocarbons, we suddenly discovered them and suddenly began to pour into the atmosphere over the course of, over the course of a century or two, and really over the course of the last few decades, many, many, many hundreds of millions of years worth of biology. And as all that extra carbon began to accumulate in the atmosphere, the level of CO2 began to rise steadily. That's what they were measuring at Mauna Loa. By the time that Jim Hansen gave his testimony in Congress, that 275 parts per million had become about 350 parts per million. And he said, it will only be a matter of years before this becomes broadly and easily noticeable by the general public. In fact, in the quarter century since, the main surprise has been how hard and how fast this change has come upon us. Much harder and much faster, even than those of us who took a dire view of this science at that period predicted. And I took a pretty dire view. I wrote the first book about this topic, and it came out in 1989, and it had the cheerful title, The End of Nature. Okay? But I didn't expect the change that we've seen, the scale, the pace, the magnitude. If you look around the world today, you see astonishing change. We've basically melted the Arctic. About somewhere in the order of 3/4 of the summer sea ice in the Arctic has disappeared. In the last 7 or 8 years, it's become possible almost every year to sail easily through the northwest and northeast passages, things that no human being had ever done in the course of human history. That is to say, we've taken one of the 6 or 7 largest physical features on Earth, the Arctic polar ice cap, and we have broken it. And the other great features of the Earth are not that far behind. I mean, look at the oceans. This university is a Sea Grant university with a great history of studying the world's oceans. In the last 40 years, those oceans have become 30% more acidic. Think about that. This is a planet where 3/4 of the surface of the Earth is covered by ocean, and we have fundamentally altered the chemistry of that. We, 25 years ago, did not even believe that that was possible. No one was even really studying it. That we could change the pH of the world's oceans seemed an astonishing stretch, but it turned out that we could and that we have, and at great detriment already to the creatures at the bottom of the marine food chain, most of whom depend on the calcium chemistry of the ocean in order to form their shells, a process that's becoming disrupted in very dangerous ways. So far, human beings have increased the temperature of the Earth about 1 degree Celsius, 1.8 degree Fahrenheit. That does not sound like that much. And it isn't, in some sense, that much. If you do the calculations, the carbon that we've put in the atmosphere is increasing the amount of solar energy that we accumulate per square meter of the Earth by about 3/4 of a watt. 3/4 of a watt per square meter, so less than one of those small white Christmas tree lights per square meter of the Earth's surface. Not much, except that there are a lot of square meters on the surface of the Earth. And when you aggregate it all, the numbers look rather different. The heat equivalent at the moment is about 400,000 Hiroshima-sized bombs a day in extra heat that we are trapping because of the carbon that we've poured into the atmosphere. And that 1 degree so far has been enough to cause not only that melt in the Arctic and not only that change in the chemistry of the ocean, but also all kinds of other effects. A way to think about it is less as global warming and more as energy accumulation in this narrow envelope of atmosphere in which we survive. Pretty much every physical phenomenon on Earth, except volcanic and tectonic forces, are driven by that quantum of energy that we accumulate from the sun, okay? And so if you trap more of it, you amp up almost everything that's going on in the world around you. So, for instance, evaporation. In a warmer world, you evaporate more, and hence you have more drought, something that Texans are becoming familiar with as time goes on. In fact, people across the southwest and the west of the United States, I was at Hoover Dam, Lake Mead, a couple of weeks ago, looking at the enormous 100-foot-tall bathtub ring as that lake drops behind Hoover Dam, because we are in the middle of a remarkable drought across this part of the world. California last year had the driest year that it has ever measured. And the result of that kind of drought and the result of the record temperatures, Texas and Oklahoma in 2012 and 2013 recorded the hottest summers ever recorded in the United States. The result of that is not only drought, not only problems for agriculture, but remarkable changes in basic ecosystem composition. Forest fire season now lasts an extra 6 or 8 weeks at either end of the fall and the spring, and so you see enormous blazes of a kind that we did not see in the past. And when you see those blazes, you see more carbon added to the atmosphere as those trees burn, and you begin to see the kind of cycles that feed back in dangerous and powerful ways. There are lots of these feedback cycles on this earth. We're beginning to worry a good deal about the fact that as we raise the temperature of the planet, we're melting tundra and permafrost in the north, in the far northern hemisphere, in the Arctic. And beneath that tundra and permafrost is trapped a great deal of methane, CH4. And the molecular composition of methane makes it an even more potent greenhouse gas than carbon dioxide. The net result of all of this is that we are at the very early stages so far of climate change. And the forecast of the various scientific bodies of the world is very dire. We've raised the temperature 1 degree so far, and that's already caused great problems. The scientists have attested to those problems, and if for some reason you don't trust scientists, then ask the people in our economy who we assign the task of judging risk, the insurance industry, and they will tell you exactly the same thing, that their payouts each year from weather disasters and things rise, and there's no other explanation than the rapid warming of the earth. But that 1 degree is child's play compared to what's coming. The same scientists who predicted it now tell us with confidence that the temperature of the earth on current trajectories should rise 4 or 5 degrees Celsius, 8, 9, 10 degrees Fahrenheit before the century is out. If that happens, then we really cannot have civilizations of the kind that we are used to having. The most basic things begin to change. Sea level begins to rise and rise dramatically. It's already rising. That's why storms like Hurricane Sandy were so devastating. New York Harbor is a foot or a foot and a half higher than it used to be, and so when that storm come along, it turned Lower Manhattan for a while into an arm of the ocean. It flooded the New York City subway system with the Atlantic Ocean. It becomes very difficult to do agriculture as we are used to doing it in that kind of scenario. The teams at Stanford and the University of Washington, in their big meta-study of agricultural impacts a couple of years ago, predicted that from this point on, each degree increase in global average temperature should reduce grain yields roughly 10%. We got a sense of how that could happen in 2012, which was by far the warmest year in American history, and a year in which we saw essentially a crop failure across the American heartland, across the richest agricultural terrain on Earth. If that 10% per degree figure is anything like accurate, think about the future. Think about a world 2 or 3 degrees warmer. Think about, therefore, a world with 20 or 30% fewer calories on it. Then try to imagine what that world is like in terms of strife and division and war. It's not a scenario that we can afford in any way, afford morally, afford economically. The biggest economic studies of this future, the one maybe most prominently conducted by Lord Stern, the British economist, a couple of years ago, concluded that the total cost of unchecked global warming would be larger than World War I and World War II and the Great Depression combined. We don't have that kind of money, and we don't have that kind of margin anymore. The most important thing that's happened in the lifetime of everybody in this room is that our planet has emerged out of the Holocene into something else for which we don't yet have a real name. And the only question is how far into that something else we plan on going. We've raised the temperature 1 degree so far. The question is how much further do we raise it? And in a sense, that's a question not for chemists and scientists to answer, but for political scientists to answer. In fact, for all of us as citizens to answer, because it's a series of choices that we will make in the next few years that will tell us how far into that world we go. There's nothing inevitable about the world, about this prospect. There are ways in which we can intervene still to keep from going off this cliff, at least completely. If it is too late to stop global warming altogether, it is not too late to keep it from getting worse than it has to get. But it will take disciplined and powerful action over the next few years in order to accomplish the kind of things that need to happen. The good news is that your colleagues in the engineering departments have done much of the work that needs to be done to allow us to imagine what the future looks like. 25 years ago, when we wrote about solar power and wind energy and things, we did it kind of with our fingers crossed because it was not yet ready for prime time and we didn't really know if it would ever be. But human beings are good at engineering, and so we have figured out a lot of things. There were days last week, when the state of Texas supplied more than 1/3 of its electricity from wind power. That's a remarkable advance given how little public policy there's been behind this shift. It's a signal as to what we could do if we really set our minds to it. There were days last summer when Germany, the country that's worked hardest to move in the right direction, there were days last summer when Germany supplied power that it used from solar panels within its borders. And this is Germany, not a very sunny place at all. Most Germans are as pale as I am. They don't have much in the way of sun, but they have a great deal of political will, which they have deployed to make sure that they take advantage of what resources they have. There are more solar panels in Bavaria than there are in the United States. Okay? So think what a country could do that had California, Texas, Nevada, Arizona, New Mexico, Florida to work with. We're surrounded by resources, and the question is whether we will make use of them or not. And here we move from the easy terrain of science, which has pretty clear answers about things, into the murky terrain of politics and how we make change and why we have not made change yet on a scale necessary to deal with this problem. And I fear that the reason, above all, that we have not made change on the scale that we need to is because of the enormous power of the fossil fuel industry, which is the richest industry in the world. Your Texas company, ExxonMobil, made more money last year than any company in the history of money. Okay? And in our political system, money buys a certain amount of power. In fact, a lot of power. In fact, so far, enough power to prevent reason and science from having the effect that one might hope it would have. So far, Washington has had a 25-year bipartisan effort to accomplish nothing in relation to climate change, and it's been entirely successful. And really, that explains why I've spent the last 5 or 6 years doing what for me is very strange stuff to be doing. I'm a writer by nature. Writers are introverts. We like, well, I like to be here with you all. It's pleasant, but really I'd rather be at home in my room typing, That's what I really like to do. But at a certain point, I began to figure out that another book was not going to move the needle on this question of climate change. And so the question became, what could we do instead? The fossil fuel industry has all the money. So there was no possibility of outspending them, spending more money in Washington, lobbying, buying more congressmen, doing more of that. That was not a possibility. We had to find a different currency to work in. And the currency that we thought we needed to use was the currency of movements. Movements like the civil rights movement that relied not on money, but on passion and spirit and creativity. And so we set to work 6 or 7 years ago to try and build for the first time a kind of global movement for this global problem. And when I say we set to work, I mean myself and 7 undergraduates, people your age, at the small college in rural Vermont where I teach. And we decided we would form a kind of campaign. And the first question was what to call ourselves, what image to use to kind of rouse the world. And we turned to chemistry for the answer to that question. Instead of picking some slogan, we picked a number, a data point. In 2008, our most gifted climatologist published a series of papers in which they said, for the first time, we really know to a fair approximation how much carbon in the atmosphere is too much. You remember that I told you that during the Holocene, 275 parts per million was the more or less baseline. And in 2008, what those scientists said was, we can say with some certainty that any value greater than 350 parts per million is too much. It's possible that it's lower than that, but above that level, they said in the abstract of their paper, above that level, above 350 parts per million, we can't have a planet similar to the one in which civilization developed or to which life on Earth is adapted. If you are used to reading scientific papers, that is strong language. Stronger still when you know that wherever you are around the world, in Texas, in Tijuana, in Toronto, in any place, the atmospheric concentration of CO2 is now above 400 parts per million and rising 2 parts per million per year. Already too high. That's why the Arctic's melting. So there were people who said, don't pick this name for your group because it's too complicated and because it's too depressing. We're already past it. But we thought there were two important things. One was that it was useful to be real. In the same way that going to the doctor, you know, is real. If you go to the doctor measures your cholesterol. Not your cholesterol is all still fine, but when you're a little bit older, they measure your cholesterol, and the doctor will say, your cholesterol is too high. You're in the zone where people are going to have heart attacks, you know. And when people hear that, that's the point at which they start taking their pill and jogging and eating right and doing those kind of things. We thought reality was important. We also wanted to take this number because we were going to organize around the world. And one of the difficulties about organizing around the world is that everybody in this planet insists on speaking their own language. And so it is difficult to pick a slogan or a name that works. But Arabic numerals move easily across those linguistic boundaries. And so we chose 350.org as the name for this campaign, and we set to work. There were, as I said, 7 undergraduates. There are 7 continents. Each one of them took one. The one who got the Antarctic also had to cover the internet, okay? And so we set to work, and our work was to try and find people like ourselves around the world who were worried about this. They're not every place on Earth somebody called an environmentalist, but there's every place on Earth someone worried about hunger, about public health, about war and peace, about all the things that you can't have in a world that's beginning to disintegrate. And those were our natural allies. And we fanned out around the world and tried to find them. And a year after we started, we tried to get everybody to cooperate on a sort of global day of action. Okay? We didn't know how well this would go, but we wanted to try and introduce this 350 number into the bloodstream of the planet, you know. And so we asked people to do what they could. And we didn't know how it would work. We had no money. We had no organization. But we had this idea. And so in 2009, I guess, we'd called for this day. And we got the first sense that it might work 2 days early. We were sitting around the borrowed office that we used. One room, the 8 of us around this table, and the phone rang. And it was our leader in Ethiopia calling. Like many of our leaders, she was a she, and like many of our leaders, she was 17, okay? And she said, the government has taken away our permit for Saturday. Ethiopia, not a very nice government. So we're doing it today before they can stop us. Now, she was in tears, not because she was afraid, though that would have been okay to be afraid. It's a scary thing to stand up to the government in that way. But she said, we don't want to spoil this for everybody else. We were so looking forward to doing it the same day as everybody else. We don't want to jump the gun. We hope you don't mind. And we have, see if I can find the picture here. We have 15,000 people out in the streets of Addis Ababa right now. I have no idea why there is a deck of cards in the rest of this, but we'll see if I can. There we go. This is your computer, so okay, good. We're ready to go. We know what you do in your spare time now. Yeah. We're good. We're set to go. That was an amazing picture to find, those young people out thronging the streets of Addis Ababa. And what followed was equally remarkable. Over the next 96 hours, there were 5,200 demonstrations in 181 countries around the world. CNN called it the most widespread day of political action in the planet's history. The second picture that came in, actually, came from U.S. troops in Afghanistan. They made a 350 with sandbags, and they said, we're parking our Humvee for the weekend and walking. So we have 5,200 pictures from these, and I won't show them all to you, but I'll show you just a few, partly to give you a sense of the spread of this concern and this worry. I've heard people say over the years to me, oh, environmentalism is just something for rich white people who've taken care of their other problems. If you were worried where your next meal was coming from, you wouldn't be an environmentalist. But that turns out not to be true at all. Almost all the people that we were working with around the globe were poor and black and brown and Asian and young, because that is what most of the world is made up of. And what do you know? They're just as concerned about the future as anybody else, maybe more so, because the future bears down very hard on you if you are in these places. And so there were remarkable pictures just emerging from the poorest places. There's people in dugout canoes on the Congo River, someplace above Kinshasa, near where Joseph Conrad, in his Eurocentric way, had identified the heart of darkness on our planet. And there they were. They didn't have a digital camera to take a picture, so they developed it in their home darkroom. It didn't come out so well, so they wrote in what their banner had said. But there they were, part of this fight, and there were creative and beautiful actions, all over the world. Big involvement of religious communities around the world for the first time in this kind of work, which made me very happy. I'm a Methodist Sunday school teacher, so here's South Africa. There's the head of Muslim South Africa, the head of kind of indigenous traditions in the middle. In the background, the Anglican Archbishop of South Africa, at the head of a big multi-faith march. There's Wheaton College, maybe the most important evangelical college in the country, Billy Graham's alma mater. I'd been to the Holy Land, to Bethlehem, to do some organizing, a hard place really to do much because there's so much military tension and things. But the Dead Sea is shrinking rapidly as temperatures rise, and so people wanted to be involved. They couldn't move easily enough, so the Jordanians said, we'll make a big 3 on our border. The Palestinians said, we'll make the 5 in Palestine. The Israelis said, we'll do the 0 on our beach. It was a beautiful day. 300 big demonstrations across China. Not an easy place to do this kind of thing. One of them got busted up by the police, but the others went ahead. Important, because China is an important part of this story, and they're doing a lot of things wrong, burning a lot of coal the way we did, but they're also doing a lot of things right, leading the world in renewable energy production. Those are our brothers and sisters in the Maldive Islands. Now consider the Maldive Islands. They're in the Indian Ocean. They're an archipelago of 1,200 islands strung out 1,000 miles across the equator. Incredibly beautiful. Your kind of vision of tropical paradise, white sand beaches, palm trees rising. The only problem with this paradisical vision is that the highest point in the archipelago is about 2 meters above sea level. That culture has been there for 5,000 years, but the chances that it lasts out this century are pretty small. but they're doing what they can to survive. There's the Student Government Association of the Maldives holding their meeting in the lagoon to kind of illustrate their dilemma. This was the biggest story on Google News for about 36 hours, and the reason was, I think, that the participants did not look the way that editors thought environmentalists should, you know. There's Yemen. That's one of the toughest places in the whole world right now. And that zero is all women in full black burqa. So to us, they don't look like members of the Sierra Club, you know. But really, their hearts are in the same place. They're thinking about the future, not about themselves. They're open to the world in those ways. And this is Abu Dhabi, oil-rich sheikhdom in the Middle East. So a kind of, you know, not completely unlike Texas in certain ways. And you can see some of the oil-rich sheikhs down front there in their dishdashes, those white robes. Smarter than some oilmen, however, because behind them you see the edge of what's the largest solar array on planet Earth. They're determined to stay rich no matter what, okay? And more power to them. There were also 400 or 500 pictures from the day that just ended up in a file marked 350 adorable. And they were adorable, okay? And they were also hard to look at. I look at those eyes of that girl in the middle every time I show that picture, and I just think that girl is probably going to be a refugee in the course of her lifetime. Have to leave her home in the Maldive Islands, not for anything she did, but for what we've done to change the way that this planet works. And when I look at those pictures, I'm all the more motivated to go to work. I should end here, and I will pretty quickly, just to say that the work that needs to be done to make this change is, on the one hand, not easy. The fossil fuel economy or the fossil fuel infrastructure is the most important part of our economy. It's very deep and key, and it'll be expensive to change it at the speed with which we need to. But it's also not impossible. One of the things that needs to happen is that we need to bring the power of markets to bear on this problem. The interesting thing, the reason that we burn so much fossil fuel and put so much carbon into the atmosphere is that uniquely among our resources, we allow the fossil fuel industry to pour all that carbon into the atmosphere for free. They pay no price for it. They're allowed, the Exxons and the Chevrons and the Shells of the world, to treat the atmosphere as an open sewer into which they can pour those byproducts, that pollution, for free. They externalize the cost, as the economists would say, and as a result, we use far more of this than we would, and we move less quickly than we otherwise would toward renewable resources. And so the hope is that we're able to persuade our politicians to bring market forces to bear on this problem. But that's difficult to do because of the political power of those industries. I mean, before the last election in 2010, Chevron gave the largest single campaign contribution of any corporation in U.S. history, and it was designed to make sure that the House of Representatives stayed in the hands of people who would do nothing about climate change, and it was successful. And that's what I mean when I say we need to build a movement. We've gone on over the last 5 years to hold about 20,000 rallies in every country on earth except North Korea. We've gone on to try and spearhead the opposition to new development of oil projects like the Keystone Pipeline across the middle of this country that would bring the dirtiest oil on earth down to Texas to be refined. We've spearheaded a large and growing movement to get institutions like colleges and universities to divest their stock holdings in fossil fuel companies to send a political message. A campaign that's gone very well. Oxford University said it was the fastest growing such campaign in history last fall, earlier today. A huge slice of the faculty at Harvard sent a letter to the president of that university demanding that Harvard divest its holdings in fossil fuel. So this movement is growing and growing rapidly. It still is not as strong as the fossil fuel industry that holds sway in Washington, but we are trying without money, but trying with other means of influence. And I hope that some of you will decide to join in that movement, that some of you will decide in your role, both as scientists someday, but as citizens, to be part of this drive that has to happen in very short order if we are to deal with the deepest trouble that we have yet stumbled into. I cannot promise you that we will be successful in this fight. The science is pretty dark. The fact that we've already melted the Arctic is a bad sign, okay? But I can promise you, because I have been all over the world, that there are a lot of people who are ready for this fight, who are doing what they can to stand up for the future. And that future will be decided in the course of the next few years. There are people lining up to try and make change, and some of them coming from unlikely places, coming from our church communities, coming from our military communities. The head of U.S. forces in the Pacific, Admiral Locklear, said last year that when he and his colleagues get together to game out the threats to U.S. national security in the years ahead, the thing that troubles them most is not Islamic terrorism. The thing that troubles them most by far is this change in the basic stability of the planet. Because if you starve people, and if you raise the level of the ocean, and if you put people in motion around the world needing to escape the place where they live, then the instability that follows is an enormous threat. That's the future that we face unless we take action. The future that we face if we do take action is a sweeter one that runs off wind, one that runs off the sun, one where energy has been decentralized the same way that information has been decentralized in an internet age, a world where it's not a few powerful countries and corporations that dominate our energy landscape, but where there are millions, tens of millions of solar panels on tens of millions of roofs, and we have linked together our energy infrastructure the same way we have our information infrastructure. This is probably the most decisive choice that human beings will make, and because of the chemistry and physics, we have to make this choice soon. If we don't make this choice in the next few years, then the choice will be made for us. We will have gone past the point where we have any real control over the outcome, which is why I'm not at home in Vermont, where I live, where I'd like to be, but why I'm here with you and why it's a pleasure to be here with you and to say to any of you that want to get involved in this battle, it'll be a great pleasure to stand shoulder to shoulder with you in the years ahead. Thank you very much.